Hello, everyone. Can you all hear me and see the slide?
Yes, everything is working well.
Perfect. Thank you for everyone sticking around. It's been a full day of fantastic and really illuminating conversations and presentations, and I'd be happy to engage in that. And I'm also looking forward to tomorrow's sessions. I'm speaking to you from University of Virginia in Charlottesville, where I am an assistant professor in both architecture and urban environmental planning. And as you can see on your screen, I'm pretty bad at titles, titling talks. This is already different from the one that's on the schedule. I was debating whether to code SMART or not. And I ultimately arrived at it. And part of this has to do with the uneasy feeling that I think it's quite shared from the presentations today with regards to the term SMART. What the connotations are for the city that is not smart, and so on. A while ago, I wrote a paper looking at smart city literature, which was really focused on Europe and North America. And I was really struck by the fact that almost every paper had to develop a working definition of smart before getting into their argument. And I'm starting to realize that the vagueness is perhaps by design. And this is really the context in which my work attempts to decode the socio-technical systems that are at the base of database forms of urbanism. I have a lot of videos in my presentation. I hope they come across clearly and not choppy. Okay. Okay, so I'll start with two Super Bowl ads. They're roughly 10 years apart, both of them by Salesforce. For those of you not familiar, Salesforce within the American cloud market is basically like the very quiet family member that for some reason has a lot of connections to very high up people. But what I found really interesting with regards to these two ads specifically was that the foundational ideologies of technologies that are embedded front and center within both ads. One, that technology can seamlessly and effectively respond to social and political issues, which again brings with it the techno-positivistic ideologies of progress. And two, the ideology of the frontier, which has been at the core of techno-utopian thought for some time. For our discussion, the notion of technological progress and the frontier are critical, since these same ideologies inform how technology firms view and act in cities. The city is treated as a frontier of data-driven projects that attempt to deal with a variety of socio-technical issues facing contemporary urbanization. From parking spaces to healthcare, nothing seems to be outside the purview of tech. In the background, the machinery of myths and marketing represents the spatial projects of tech as part of a singular, clean, objective, and transformative platform logic, which further imbues the urban operations of data platforms with techno-utopian ideas of progress that attempt to justify the colonization of everyday life through technology as a necessary consequence of responding to the socio-environmental challenges of urbanization. And here I'm mainly focusing on large multinational corporations like Google and Amazon, realizing fully well that smart urbanism is not only limited to these large corporations, but given the scale and the impact that these corporations have, they become indicative of the larger field, but also the fact that their platforms become the underlying infrastructure of other smaller companies. The tech sector's strategists, now turned urbanists, position themselves and their platforms as harbingers of a new smart, even conscious paradigm of urbanism. An urban model in which every click, every sensor, and every screen is linked up to clouds of data that depend on infrastructural landscapes, material geographies, and operational extensions that increasingly encompass the globe. Yet in all these cases, the urban projects of tech platforms, and by extension the city, are portrayed as highly defined entities with very clear boundaries, a wholly knowable, manageable, and ultimately controllable archipelago in a sea of an undefined periphery. Yet the power that tech corporations wield in cities is as highly dependent on the organization of the sea as it is the archipelago. For example, Google has spent more than $30 billion on its cloud infrastructure over the last decade. Amazon has spent $35 billion on data centers in Northern Virginia alone. Microsoft, Amazon, Google, and Facebook have invested so heavily in undersea fiber optic lines that their private network's bandwidth capacity now completely overshadows the backbone of the internet. And as the computational logic of digital platforms begins to dominate urban life, tech corporations leverage this planetary geography to exert ever more control over the organization of urban spaces and the people whose data they really depend on. And this is really the enabling geography of the cloud. The hypervisibility of tech's spatial projects within smart cities masks and obfuscates an extended geography of extraction, processing, storage, transmission, and control that underlies the ideologies, practices, and forms of smart cities. This is the infrastructural space that mediates the urban operations of platforms and their data supremacy. A global operational landscape, which is dominated by cables, data centers, extraction sites, tech campuses, and manufacturing plants that quite literally tether the cloud to the ground. The takeover of urbanization by technology platform is therefore predicated on the buildup of computing resources and the enclosure of material geographies that are often not situated well outside of cities. Within this process of constructing planetary platforms, this process entails a particular territorial hybridity, which puts data-driven control and management of concentrated moments of urbanization in cities in direct relationship with infrastructural extension and increasing operationalization of the erstwhile non-urban periphery. Therefore, to fully capture the urban impact of technology platforms, we need a reframing of smart urbanism, or the place that smart urbanism happens in. One which goes beyond the city to situate its technological positivism within the spatial complexities of its construction. And by complicating the spatial geography of tech platforms in this way, we can begin to peel back the transcendent veneer of tech urbanism to reveal how data clouds are firmly tethered to the messy geopolitics and the uneven material geographies of global urbanization. As an initial step in this reframing, mapping and drawing the constitutive sites of data platforms and their contextual relationships can perhaps be helpful in producing a spatial understanding of the geographies that are activated through their continual expansion. As a way of giving this some structure, I've roughly categorized the operational landscapes of tech platforms into 4 territorial strata. Farms, or purpose-built large-scale data centers and their associated energy projects. Pipes, or the physical networks of delivery and control of data. Mines, or the extraction sites of materials essential to data devices. And enclaves, or corporate headquarters of technology companies and their bounded smart city initiatives. And before this presentation, I was really debating how to go about unpacking all of these different categories, and I thought it might be best to unpack one as an example. And I picked really the low-hanging fruits, and that's data centers. The regions and zones of the cloud are essentially materialized through data centers, which are in turn grounded within the specificities of geography and location. Locating the physical infrastructure of the cloud entails a spatial logic based on a cocktail of economic, political, and environmental conditions. whether a region is earthquake prone, bound to political instability, or climatically extreme, as well as factors such as energy reliability, fiber connectivity, proximity to major target markets, are all deciding factors. In locating its nodes, the cloud has followed in the footprints of previous rounds of capitalist spatial production. Data centers are often located on top of the ghosts of manufacturing economy or within the spatial vestiges of the military-industrial complex of the Cold War. Beyond its locative moves, a typical data center's defensive spatial strategies use topography, vegetation, and hard barriers like fences and walls to cut it off completely from its immediate context while maintaining heavy dependence on regional infrastructures of power, water, and data. Therefore, space and its construction play a critical role in how the cloud grounds itself. As the workhorses of the information economy, data center investments have become quite attractive for states and cities whose economic base is moving from primary production towards more of a service-driven industry. North Carolina is among such states in the US that have lobbied heavily for data center investments. Things like favorable tax regulations and relatively inexpensive land and location in relationship to major population centers have contributed to a kind of a data center rush in the state, a rush that began with one of the first purpose-built Google data centers in Lenore in 2007, and which was followed very quickly by the likes of Apple and Facebook, contributing really to the buildup of a data center geography in the state. The specificities of geography and sociopolitical dynamics bound the infrastructure of the cloud into identifiable clusters. For instance, this is the cluster of Google, Apple, and Facebook data centers right outside of Charlotte in North Carolina. While each data center project has its specificities in terms of design and location, they also share a lot in common. Direct access to highways and location on elevated or otherwise hidden places is a common trait. Also, access to an available workforce and surplus infrastructure is a must. And this is quite evident in Google's Lenore project, which as a previous hub of manufacturing, Lenore used to be the furniture manufacturing capital of the US for quite some time. Small industrial towns like Lenore present especially potent sites for grounding the cloud. Years of industrial development mean the availability of surplus infrastructural networks of water, electricity, and transportation, which are now available cheaply and abundantly as manufacturing has moved overseas. Inexpensive land and political willingness of local governments are also important factors and have translated to massive tax incentives for companies like Google. And this is just to show how the context of Lenore has transformed spatially in relationship to the ever-expanding footprint of Google's data centers. We basically go from a relatively small $600 million data facility in 2007 to the construction of a second facility in 2010, and ultimately to now a $1 billion data campus, which begins to spatially compete with the rest of the city. And while the spatial projects of the cloud are always touted for their economic regeneration potentials, their actual effect on the economy of these contexts remain minimal. Google's Lenore data center was, for example, imagined for a long time to be a vital morale booster, if not a full replacement of lost furniture factories and the jobs that came with them. However, in actuality, in actuality, Google has only generated about 250 jobs in Lenore, some of which have been construction jobs, so quite temporary, and most of which are actually held by people that are commuting into Lenore from outside the county. So this is also in the context of more than 300 jobs that have been lost since Google came to town in 2007. So in conclusion, the intertwined relationship between narrative and material impact on the ground is key to an ultimate reframing of smart urbanism and other vague socio-technical platforms. By unpacking the urban implications, spatial imprints, and material geographies that form the foundation of smart cities and artificial intelligence, we can begin to generate a critical framework for examining the real toll that the expansionist logic of digital platforms entails. The scrambling for resources and territory that this logic exacerbates is likely to create more territorial conflict, more social exploitation, more geopolitical strife, and obviously more environmental degradation. The spatial reality, which is far removed from the frictionless egalitarian dream that propagates the base of technological progress. By externalizing these moments and hiding them behind screens, tech platforms essentially evade responsibility and avert attention from the grounded dynamics of technology. Exploring both the social and the spatial basis of the cloud's construction begins to reveal the environmental and social costs of data technology that are not captured within the positivistic narratives of platforms. Thank you.